I throw one last thing at you. Now, go over your answers. I don't even know how you can see all the way back there, but okay. So we noticed in this one that we have a sine and a cosine. You can't solve one equation for two variables. So out of cosine and sine, which one can I change? Out of cosine and sine squared, which one can I change? Sine squared. I have an identity for this. This is the one identity that you have to memorize. This is Pythagorean's identity. It's actually the same as x plus x squared plus y squared equals 1. Cosine squared plus sine squared equals 1. So cosine and sine are the most basic. You can't change those. But this we're going to replace with this. We're substituting it out right in here. Distribute. Notice you've got an x squared, if you will. This is the highest one over here. So you want to get them all to one side. I don't care which side you move them to, but when you're done, make sure your leading coefficient is positive, or you're not going to be able to factor it. So I just moved mine to this side. So now this is the same as saying 2x squared plus 3x plus 1. Remember, these factors are not a lot of big choices here. They're all positive, so there's only one way to possibly factor this. 2 cosine plus 1, cosine plus 1. Set your factors equal to 0. Now, and it feels like we've done a lot of these time and time again, because look at the answers. We're not possibly getting a lot of things. 1/2, radical 3 over 2. The quadrants keep showing up a lot. Those are your 1s and 0s. So where is my cosine negative? Quadrant 3, 2, and 3, wherever my x is negative. Okay, so we had to leave this one as all solutions. So it's a 60-degree angle. So this is 3 pi over 3. So I'm 1 short, 2 pi over 3. 1 more, 4 pi over 3. And we add the plus 2n pi, where n is any integer, because these are looping around and around and around and around. So all solutions means it's continuous. Okay? Questions? This is a good time to ask them. Because this kind of wrapped up what we've been working on. Okay. Tangent, this guy, I think we've even done this one before. You can factor it into your perfect squares if you like. You can set that equal to 1, take the square root, it doesn't matter. You will come out tangent plus or minus 1. What angle has a tangent of 1? 45. That's the odd one. That the one is not a quadrant angle, it's a tangent. So all quadrants, because I've got positive negatives, of a 45. So if I say this guy, and just pi over 4, if I add n pi, I come to this one. If I list this one, 3 pi over 4, and add n pi, I come to this one. Instead of listing all 4 plus 2n pi. Is it wrong if you list all 4 plus 2n pi? No, but we can take this shortcut. Because the tangent, first of all, only has a period of pi. So it would enable us to do that even if it wasn't plus or minus. But this one happens to work out because it's plus or minus. It's in every quadrant. But remember, you're solving your algebraic part first, then you're going to your trig part. Questions? I think we even saw this one a few times. Like, again, there's not a lot that you're going to see. It's just kind of repetitious. So, Gabe, what we're doing is solving the equations like we would any trig equation. And then once we get here, we're finding the angles that correspond to those. If we say all solutions, that means this because your curves are continuous. So we want to find plus n pi or plus 2n pi. If it's across from each other, we can do half the circle. That's 180. That's n pi. If it's like this guy, we have to come back around. That's 2 pi. All right. This guy, very similar to the last one. I have all 4 quadrants, so my tan is positive and negative in all 4. But now, when I take the square root, I get radical 3. Put it over 1. Tangent is y over x. The only difference here is not a 45 angle, it's a 60-degree angle. But it's the same concept. So 60 goes into 180 3 times. So this guy gives me pi over 3 plus n pi. This guy gives me 2 pi over 3 plus n pi. That's my all solutions. That's my way to start this. X is equal to pi over 3 plus n pi. X is equal to 2 pi over 3 plus n pi. Now, it asks for your solutions between 0 and 4 pi. How many solutions did we have between 0 and 2 pi? How many triangles do you see? 2. All together? 4. So if I have 4 angles from 0 to 4 pi, how many should I, from 0 to 2 pi, how many should I have to 4 pi? 8. I should double it. I should times it by 2. I should double it.
Wait,
now,
so there are 4 in 2 pi?
You told me. There's 4 angles. This was all solutions. We only had to list 2. But if I listed it, this would be 6 pi. So I would have pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Those would be all my angles from 0 to 2 pi. I'm going to do it one more time around. Now, because you're only going one more time around, if you want to, make this 9 pi over 3, make this 12 pi over 3, and you can continue. You can say this. If this is 6, what's 1 more than 6? 7 pi over 3. If this is 9, what's 1 less than 9? What's 1 more than 9? And what's 1 less than 12? 11 pi over 3. Here's my angle. From 0 to 4 pi. If you want to do that, because you're only going around one more time, just keep your pattern going. Life is about patterns here. If not, from 0 to 4 pi, what denominator are we working in here? What's my denominator? So let's convert this to thirds to see where I should stop. So what's 4 times 3? 12. Okay. Now, I'm going to do the same thing here. I have to add n pi. I have to add 180 degrees. Pi every time. So convert this to thirds. So times 1 times 1. I'm going to add 3 pi because look at my denominators now. They're the same. So when we add, don't we want a common denominator? Add our numerators. So if I start with pi over 3, and I add 3 to this 1, what do I get? 4 pi over 3. If I add 3 again, what do I get?
7 pi over 3.
If I add 3 again, what do I get?
10 pi.
Good. Now if I add 3 again, I'm 13. I'm out of the 12. I only wanted to go up to 12. So I stop. I go to my other angle. This is the same denominator. I'm going to add 3 pi. So I'm going to start at 2 pi over 3. I'm going to add 3 to my numerator. So what would that give me?
5
5 pi over 3. Add 3 again.
8.
And add 3 again.
11.
And if I went one more, I'd be out of my 12. So isn't this the same thing that we found over there? Right? So since you're only going one more time around, whichever way you prefer to do is fine with me. Good? I know you can do this. You can do this. You just got to think this out. And I know these have fractions in it. You just got to convert them to a common denominator. Because once you have a common denominator, you can add your numerators. Okay. Again, we saw this one the same as number 1. Once you go to factor this, once you factor this factors, and I think Venetia saw it yesterday, right? I think you saw this one yesterday.
Yeah.
Once we take this, once we replaced your other with the cosine, it came out to look like this one. So it's the same startup as this, but then we asked you between 0 and 4 pi. So let's start this guy. Now I'm adding 2n pi. What's my common denominator that I need? I can't add those, they have different denominators. So what's my common denominator? 3. So what's 3 times 2? 6. So every time I do this, I'm going to add 6 pi. I'm going to start with 2 pi over 3. Add 6 pi. Add 6. 8 pi over 3. Okay, so I'm going to get, I had 2, if you remember back, we had 2 in 2 pi. So we're going to get 4 in 4 pi. So that's going to be good. So then I do the second one. And again, I convert this, and I add 6 to my numerator. I start with 4 pi over 3, add 6. 10 pi over 3. Okay. Now, I got to do the same thing for this guy, for this part. I can't forget this part. So this part, and if you want to just count it, if this is sitting here, again, at pi, and I've got to go one more time around. This is 2 pi. I don't want 2 pi. This is 3 pi. So I get pi and 3 pi. I can get those kind of nice, going from 0 to 4 pi. Can everybody do this part? Yes? Means you guys all have this? Yes? I need to know. Okay. We're all in cotangent. So x squared plus 2x plus 1. We're not a lot of choices to factor. Both of them are 1s, factors of 1. So it turns out to be the same factor. So do I have to do it twice? No, just once. So if you prefer to look at it as tangent, tangent is just its reciprocal. It is also negative 1. What angle has a tangent of 1? 45. And where is tangent negative? 2 and 4. So if I find all solutions, all I have to do is label this guy right here. Because then if I add 180, don't I always keep finding it? 180, 180, 180. So this guy is 3 pi over 4 plus n pi. And if you just had to find it from 0 to 2 pi, this is 3 pi over 4. This is 7 pi over 4. That was nice. I mean, we're not getting really large factors because your special triangles, their sides are not that large. They're 1. Your unit circle goes out 1. It can't be more than that. 1, radical 2, 3 maybe, radical 3. Okay, and the last one. Now this one you had to change the identity. But we said yesterday, if you started with your cosine squared plus sine squared, we had this one yesterday, and you needed to get a tangent. Tangent, I need sine over cosine. Okay, so now, if I do this, this is going to say, I've got an equation, this is going to give me my tangent. I need to divide everybody by cosine squared. This will give you your identity. So 1 plus my tangent squared equals my secant squared. This is the one I can replace with this guy right here. I can replace it with that. And I needed to get a tangent word in there. This way everybody's in tangent. And you don't have to memorize that one. You just have to know that once you get your cosine squared plus sine squared equals 1, either you divide by cosine squared or you divide by sine squared. That's all.
Where did you get the 1 plus? Isn't the 1 become negative?
Which one is negative?
Oh wait, no. Where did you get the 1 from?
This one?
Yeah.
Cosine squared over Cosine squared. Yeah. If you divide this term by cosine squared, you have to divide everybody by cosine squared. Because I wanted to get the word tangent in there to have the same function. So I can replace my secant squared with my 1 plus tangent squared. So I do. And now I replace this with this. So I collect my like terms. A 1 and a negative 1 cancel out. I've got tangent squared. It's the same as x squared plus x. I'm going to factor out an x. I'm going to factor out a tangent. So my tangent is equal to 0, and my tangent is equal to negative 1. We've been seeing that one. That's your 45-degree angle. We just did that in the last problem. This is the one we just did in the last problem. And tangent of 0, the tangent of 0, if you think of your graph instead, where does it hit 0? At the 0. Right? It hits it at the 0. I pick up my calculator. Second tan, 0. Who has an angle of 0? 0 does. You can use that in your calculator as well. And so about all solutions, I just say n pi, because your period for tangent is pi. So every pi it will repeat. Yes?
If the ones cancel out, and where did you get the tan equation?
So we took this equation, and we substituted in this identity in place of secant, right? Then I carry the rest down, and then I subtract 1, move this. I put everything on one side, or I subtracted 1 from both sides. You can do it that way, it doesn't matter. And now I said, on the same side of my equal sign, what is 1 minus 1? 0. Or I could say negative 1 over there. Take out my 1. So now I have tangent squared plus tangent. And I'm going to take out what they have in common, a tangent. Because if I did this, x squared plus x, what would you factor out of x squared plus x? X. And that would leave you with x plus what? X plus 1. So when I factor out a tangent, it leaves me with tangent plus 1. Okay? If you wanted to, you didn't have to put it on the side. You could just say minus 1, and take it away right there. Okay? The variable is what now? 3x. That means 3 times my angle. So this tells me I have a multiple angle. I have a multiple angle. So I'm going to work my whole statement as if it was 1. And then I'm going to deal with the multiple angle at the end. Now, if I multiply something by 3, I should get more, right? So if I find how many angles are there that satisfy this, and I multiply them by 3, I should get triple the amount of angles. Which, when you guys did this in Algebra 2, all we asked you to really do was never find the angles. We just asked you to find the cosine and the sine. Which I could never understand why we didn't have you find the angles, because it made, and I've taught Algebra 2 for many years, and I had my kids find the angles because it makes more sense when you find the angle, not the cosine of it. Who cares what the formula says? You need to see the angle. So what we're going to do is we're going to solve this as if this was x. So if I solve this for x, I say 2 cosine x minus 1 equals 0. I add 1. I divide by 2. And I have the cosine of x equal to 1/2. Agreed? Now, where is cosine positive? 1 and 4, wherever x is positive. Cosine is 1 over 2. So what angle is this right here? 60. So how many times does 60 go into 180? 3. So if I write all solutions, I'm going to do my all solutions. We're going to start like this. It would say x is equal to pi over 3 plus 2n pi it would say x is equal to, what would my other angle be? 5 pi over 3 plus 2n pi. Okay, good so far? Just like we did, just like we were doing before. We found out from 0 to 2 pi, and then we can figure out plus 2n pi, plus n pi, whatever we needed to do. Now, at this point, we're going to go back and we're going to say, but it wasn't x. What was it? 3x. So we're going to come here and put the 3 back. And if I have two angles in 2 pi, and I triple them, how many angles will I now have? If I had 2,
15.
well, no. If I had 2 from 0 to 2 pi, and I triple that amount, I will have 6 from 0 to 2 pi. So let's see if this is true. So this is how we work this. We solve it, and then we say, okay, let's get this back to x. Technically, if I took 60 degrees, and I needed to make 3 of them in place of one angle, how many degrees would each one of them have to be? 20. So I'm technically saying 60 divided by 3, right? So I'm going to divide everybody by 3. I got to get rid of the 3. So I say, okay, x, and 60 divided by 3 is 20. But when I flip this, I get pi over 3 times 1 over 3. This gives me pi over 9. How many times does 9 go into 180? 20. So aren't I at a 20-degree angle right now? Yep. But I need to keep this in radians. So pi over 9 plus, and I just keep this, 2n pi over 3. Just start like this first. So then I take this guy too. I need to solve for x. So I end up with x is equal to, if I flip that over, what do I get? Over 1 times 1/3, right? It would be 5 pi over 3 times flip this over, 1/3. What would I get? 5 pi over 9 plus 2n pi over 3. And this is where n is any integer. This is my all solutions. This is my all solutions. Now I noticed that if I take my angle and I divided it in 3 times, it was every 20 degrees. That would give me the multiple of 3. So now to find them all in radians, I'm going to do the same thing we did before. I'm going to say 2 pi. What common denominator am I working in right now?
3.
Not 3, 9. I'm going to have to convert this guy to 9 if I'm going to add them, right? So I'm going to convert this to ninths. I just need to know where should I stop. So how many ninths do I'm going to do? 18 pi. When I hit 18 pi over 9, I know to stop. So I'm okay here. I just need to convert this guy to ninths. So 3 times what gives me 9? 3 times my 2, I'm going to add 6 pi. Every time I start this, right? I need the same denominator, same as we did before. So let's start with your first guy. I'm taking, pi over 9. And I'm adding 6 pi over 9. So if I'm taking pi over 9 and adding 6 pi over 9, I technically keep needing to add 6 to my numerator. So if I add 6 to my 1, what do I get? This is a 1, and I add 6 pi to this. 7 pi over 9. Keep going, add 6. 13 pi over 9.
That's it.
Okay, if I added another one, I'd be over it, right? Now, doesn't this make sense? I had 1. Now, in place of 1, I have 3. I tripled it, didn't I? I'm only 0 to 2 pi yet. Now, I work the other one. 5 pi over 9. I add 6 again. What do I get? 11 pi over 9. I add 6 again. If I added 6 again, I'd be out of my thing. So doesn't that make sense? For that angle, I multiplied that by 3. So don't I have 6 angles now instead of 2? A multiplicity, we call it a multiplicity of 3. I multiplied them by 3. So much different than when we did yours. Well, you never did. Hang in there with me. You're doing great. Okay, we've seen these before. So right now, we're going to treat this as if it was just x. It says, here's my half angle. I want this to be a half angle. So now if I have an angle of 60, being a half angle, it would really double. It would be 120. I'm going to get half the amount of angles that I thought I was going to get, technically. But we don't care right now. We're just going to say, solve this. So I subtract 3. I divide by 3. And this looks very familiar to us, doesn't it? Okay, it's a 45-degree angle in what quadrants? 2 and 4. And we know this is 45. So let's go for all solutions. X is equal to what? I need to name this angle. Okay, how many times does 4 go into 180? I'm sorry, 45 goes into 180 4 times. This would be 4 pi over 4. What would this angle then be? 3 pi over 4 plus, I'm going to get back halfway across, n pi, where n is any integer. This is my all solutions, almost. We're almost there. This was my all solutions for when we did this on a regular, right? So now we're going to bring this guy back up here. And now we're going to address this 1/2 business. This is the same as x over 2 is the same as 1/2. So how do I get rid of 1/2? What should I do? Multiply by its reciprocal, 2. If I multiply this by 2, I'd rather you not divide by 1/2 because then you're flipping your fractions everywhere. So use its reciprocal, multiply everybody by 2. This becomes x. Now if I multiply 3 pi over 4 times 2, I get 6 pi over 4. What can that be reduced to?
2 pi over 2.
3 pi over 2. Plus, I got to multiply this guy also. 2n pi. Oh, sorry, 3 pi over 2. Thank you, sorry. Thank you. 3 pi over 2 plus 2n pi. Now, doesn't this make sense? Because before, didn't I have 2 angles? Now I'm going to have half as many. So how many do I have now? 1. Now, listen to me in the degrees for a minute. This angle was actually 135 degrees. If I doubled that angle, what would it be? What's 135 times 2? 270. Ah, isn't 3 pi over 2 270? So now I only have half the angles. I have to spread them out. I only have half the angles, so it makes sense. Now, this is my all solutions. So now I want to go from 0 to 4 pi. What's my denominator that I'm going to have to use? 2. So I'm going to stop at 8 pi over 2. So I'm going to start with this guy, and I'm going to just convert this so that I can add my fractions with a common denominator. So 1 times 2 is 2, and 2 times 2 is 4. So I start with 3 pi over 2, and I add 4, which I get, because I only had 1, so now in 4 pi I should only get 2. And I have 2 angles now, right? There's my 2 angles. Okay, so we still did the same thing.